Hello, good morning, my dear lovely lions. Welcome to the NEET Aspirant series, RNA series on YouTube. This is a series for all the NEET aspirants of 2025 and 2026 who want to scale up beyond the NCERT level and want to tackle those questions of NEET, apply the concept, understand the theory, understand the formulas, and also it includes PYQs so that you know that after watching this lecture you will be able to actually attempt your NEET questions, right? So gear up, my dear lions. Today we are doing the motion in 2D chapter. We have completed motion in 1D. We have also done relative motion in 1D, 2D. We have done vectors, we have done units and dimensions, we have done basic maths, and our NCERT series is going on side by side where we decode the NCERT chapters, and we are doing the 12th standard syllabus in the NCERT lines in physics, right? So welcome aboard. Hello Trisha, hello Satyashri, Madhumati, Sudhar, Karan, hello Satyashri, hello Sukanya. Good morning. And also many DNA students who probably joined the batch late and have a backlog, especially in motion in 1D or motion in 2D, then this particular session will definitely help you out. Okay, so let's begin with the class with your captain Shreyas, your physics master teacher on your Vedantu NEET English, training kids for more than 13 years, and now it's your turn. Okay, have you liked the session yet? Very good. If you have not done that, do that right now and subscribe to the channel, or else you will miss out on all the lectures which are going to go on, and you will be like, what was the channel, where was it, where is it, and you'll be lost. So subscribe, number one, you will get all the updates, and like the session so that YouTube knows that, okay, this is a student aspiring for NEET, let me show more NEET content, or else YouTube will distract you, right? Very good. And have you guys seen my Josh Talks on the Josh Talks channel? I want you to go. I have posted that link on the Telegram as well as Instagram, everywhere. Go. I want to see your comments also below that video. Okay, all my lovely lions. All right, go and post those comments below that particular video. Thank you so much if you have done that already. Let's start. Motion in a plane. What's the concept behind it? And what's the idea behind this particular chapter? See, imagine there is a Pandu. Okay, there is a Pandu, and what he does is basically he moves along this line like this, goes behind and then comes over here. This is nothing but one-dimensional motion along x-axis, 1D motion along the x-axis. Now imagine that same Pandu, all right, he basically goes up, he basically just goes along y-axis and then maybe just comes back over here. This is nothing but motion in one dimension along the y-axis. Now imagine this Pandu is going like this, coming back over here and then going like this. Both of them are happening simultaneously. Then what kind of motion will you exactly get for this particular Pandu? Okay, you are going like this till here. So maybe you are just going like this till here, and then you are returning back. As you are returning back, you are also still going up, maybe. Okay, fine, you are just still going up, and then you return, and maybe you go here, maybe you go over here. Okay, just look at this kind of motion. Looks very weird. This is definitely a motion in 2 dimension. He goes like this, goes till this point, he returns back till here, simultaneously is going up till this point and finally coming back over here, and he reaches over here. So what you notice in this entire motion, this is a motion in 2 dimensions, or basically a plane. This is a plane of the board. It is a combination of 2 one-dimensional motion. It is nothing but a combo of two one-dimensional motion, combination of 2 one-dimensional motions. Do you guys agree with it? Similarly, what will be a motion in 3 dimension be? A motion in 3 dimension will be a combination of 3 one-dimensional motions, which means that if I have a 2-dimensional motion, I can analyze the x motion separately I can analyze my motion separately. This will be in I cap, this will be in J cap. If it is in 3D, it will be in K cap. Each motion can be analyzed separately, and I can combine back all these things together to see where it is finally, what velocity does it have, what acceleration does it have, what displacement does it have, how much time it took, etc. So we can analyze them separately. Yeah. Yep. Yes, Trisha, Pandu is 13 years old. Wow. I never thought about it that way, Trisha. Yes. This should be actually a quiz question in one of the fun quizzes one day. Nice. I loved that idea. Great. So we will be seeing all the things again, but in the terms of 2D or 3D perspective, starting off with position vector. Position vector, what does it do? It's nothing but pointing towards where you are. It's like Pandu is the observer. Pandu sees Champa. You give one job to Pandu. Wherever Champa is, look at Champa. Look at Champa. Champa is there. Champa is here. Champa is here. Champa went there. Champa went here. So that vector which points towards the particle, towards the body, towards the object, from the origin, from the observer, that vector is called as a position vector. And that position vector keeps on changing if the particle keeps on moving or if the observer keeps on moving. Champa is there, but you are moving closer to Champa. You are going far away from Champa. The position vector will keep on changing accordingly. Exactly. So it points towards the location of that point relative to another object, which is the observer. Okay, it's a vector quantity. So if at all, this is the path taken by the particle, and this is our Pandu observer. This is our Pandu observer. This is our observer. Observer is also called as the frame of reference. So we'll have X, Y, and Z axis. So if the current position of the particle has some coordinates X, Y, Z, this is the current position of that particle, and this gray line represents the path taken by that particular particle. So if I show a vector like this, this is called as the position vector. This is called as the position vector. Usual symbol is R bar. R bar. This R bar will be nothing but having some I cap, having some J cap, and having some K cap. What will be those I cap, J cap, K cap? The coordinates X I cap, Y J cap, and Z K cap. That's it. So X I cap plus Y J cap plus Z K cap will be the position vector of that particular particle. Is that absolutely clear, my dear warriors, my dear lions, till this point? Very good. Happy morning, Krishna. Hello, Banot. Hello, Tanuja. Hello, Arafa. Hello, Ayush. Very good. Hello, Divya. Hello, Madhumati. Yes. Good morning. Good morning, everyone. Now that you have understood it till here, now that you have understood it till this particular point, what is the meaning of position vector and how do you basically write it? Let me just block this off. Very important formula. Next, when the position changes, I displace. Displace means I have moved from one place to the other. So that is called as displacement. And there is a vector which points from your old displacement or your old position to the current or the new or the final position. So that vector which goes from old to new or from initial to final is called as the displacement vector, which also represents the change in the position. So say for example, this was my old position or basically initial position. That's why I'll show Ri as a initial position vector. Maybe I moved like this. Maybe I moved like this and came over here finally. So along this path I have moved and finally reached at this particular point. So this would be my final position vector. This is my final or my current position. So the vector which joins initial to the final, that is called as your displacement. That is basically called as your displacement vector. So it will be represented by S bar. It will be represented by S bar. If you measure this gray path's length, the path which you have taken, if you measure the length of it, that will give me the distance traveled. The length of the path, the length of the path will give me nothing but the distance. Usually the symbol for distance is capital D or small d. And always the distance traveled by any particle is either more than or equal to the magnitude of the displacement, which kind of makes sense. You can see the length of the path will be more as compared to the straight line joining the initial and the final points. So this will always hold true. It will be only equal if the particle went in a straight line, then the displacement and the distance both will be equal. Otherwise, the path length will be more, the shortest line will be less, which is the displacement. By triangle law of vector addition, you will notice that our S bar and this initial position vector if I add both of them, A vector plus B vector, the triangle gets completed. That means final position is the resultant using triangle law. Therefore, I can shift Ri over here. I can write it as Rf bar minus Ri bar is actually the displacement vector, by shifting Ri over here. What is this? Final minus initial. What is final minus initial, guys? It is nothing but the change. Hence, I can also say displacement. Displacement is nothing but the change of position. Is the change of your position. How much did your position change by? That gives me the displacement. Is that absolutely clear? Everyone till this point? Okay. So that's how I write displacement. So initially I was, let's say, here. Finally I was here. This is the displacement vector joining the initial to the final location. So it's also time that we block this particular result. Great. Then you have velocity and acceleration. Say for example, this is my displacement. Okay, this is my displacement which has happened in some time. I can also define the velocity of the particle, how much you displace in how much time. So if I divide the displacement with the time, what I get is basically the velocity of the particle on an average. This is also called as average velocity. I have to divide it with the time, means let's say I was here at some time t. I reached this point at a time t plus delta t. So what it means is delta t is the interval of your time for which you have traveled, for which the particle has basically traveled. Delta t means the change of time, interval of time, the time gap for which you moved from here to here. I was here at 12 o'clock, I am here at 12:05. So 5 minutes is the time travel. That is the meaning of it. So I define the average velocity. The symbol for that is triangular brackets. Whenever I use triangular brackets, it means average. So if I use F triangle brackets, average force, average momentum. Okay, so whenever I use triangular brackets, it means average. So the average velocity, will be displacement by the time interval. So it will be basically S bar by t, which I can also write displacement is nothing but change of the position. Remember that it is nothing but the change of the position. So delta R by delta t. So this becomes the formula. This becomes your formula for average velocity. Okay, so I can just say average velocity is how fast displacement occurs. How fast the displacement occurs. Obviously the unit will be in meters per second. in SI, and yeah, CGS will be centimeters per second, or you can use kilometers per hour and all of that. Similarly, my dear students, oops, 1 second. If the displacement is very, very small, then the displacement will be written down as just like, ds, a very small displacement. A very small displacement will have some I cap, maybe some j cap, maybe some small k cap. It could be something like, dx I cap, dy j cap, dz k cap. What does this tell you? Small displacement in x, small displacement in y, small displacement in z together gives you that small displacement in that 2 dimension or 3 dimension. And this will happen in a very small time, and that small time will be nothing but dt. Then what I get at that particular instant, because it is a very small time, very small displacement, I will get the instantaneous velocity. I will basically get the instantaneous velocity. Just like average velocity was a big displacement on a big interval of time, the instantaneous velocity will be that small time and that small displacement. So basically it will be just ds by dt. It will be just ds by dt. Or you can also write it down as dr, change in that position by dt. That is also fine. dr by dt. Small change in that position divided by time. Okay, so this is the formula for the instantaneous velocity. Which is small displacement by small time. This is nothing but the derivative. So instantaneous velocity is the rate of change, how quickly, rate of change, basically the derivative of position with respect to time. How quickly the position changes with respect to time. As simple as that. That's your instantaneous velocity. This was your average velocity. Now that we have defined what velocity, displacement, position is, the last thing that we need to define is nothing but acceleration. And then I will show you the problems associated with it, etc. See, imagine I have a particle. It is already moving with some velocity, and after some time, so let's say this is its initial velocity, and then maybe it moves over here or somewhere here. Okay, maybe it is going like this, who knows. After some time, it acquires a new velocity, maybe over here. So that is its final velocity or velocity after some time. And this has taken a time interval. It has taken a time interval of delta t. Meaning, if you are here, let's say at 5 o'clock sometime, you are here at 5:30. That means the time interval will be 30 minutes. So this will be t plus delta t is when you are here. So because the velocity has changed, whenever velocity changes, I will say that there is acceleration. Whenever velocity means it's a vector quantity with magnitude and direction. So either I have changed the length, I have decreased the length, increased the length, or I have changed the direction. Okay, anything I do to that vector, the velocity is said to be changed. Then the particle is said to accelerate. So I will say that there is acceleration, and that acceleration on an average, because it's a big interval of time, is nothing but, the change of velocity per unit time. So average means I have to put triangular brackets. It's a vector, so I'll put a bar. Symbol for acceleration is a. So change in velocity by the time interval. That means I have to put over here final minus initial. If Pandu had 15 laddus, now he has only 9 laddus. The change in the laddus is 15 minus 9, final minus initial or whatever, right? If he finally has 15, earlier he had 9, so 15 minus 9, which is 6. 6 is the change. So always change is final minus initial. You can also write the change as delta V. There is no harm in writing it like that. So delta V by the time interval will give you the average acceleration. Obviously, the SI unit of average acceleration will be meters per second, so it will become meters per second square. So it's a good time that we block this particular result. How quickly the velocity changed in some time interval will give me the average amount of acceleration in this particular time. You can also notice there is vector subtraction involved over here. So if I want to find the direction of that average, I will take that final velocity and reverse it. First of all, I'll take that final velocity and reverse it. It will look probably something like this. And I will have to add it with the initial vector, initial velocity vector. So this would be the initial velocity. This would be the negative, sorry, I have to reverse initial velocity, not final, minus Vi. So whatever Vi is there, I will negate it. I will negate it like this. I will negate it like this. So this will be minus Vi. Final velocity is there. So final velocity is there somewhere here. So this was your final. This was your negative Vi. Negative Vi plus V final. That will basically give you over here the change in velocity. This thing is nothing but your change in velocity. Do you see that? Negative Vi plus Vf. It's vector subtraction. So this is the direction of the change. That's exactly the direction of your average acceleration also. So your average acceleration will also be in the same direction. Your average acceleration will also be in the same direction. So your average acceleration will be in the same direction. Okay, this is how you get it. Yes, very good. Very good, Krishna, Pratibha, Satyashri. Awesome, Tanuja. Very good, Mukunda, Paul. Awesome. Keep it going, guys. Keep repeating the definitions. Keep typing the definitions. It will enter your head. Even if you copy whatever I am writing on the board and type the same thing. Even if you copy the same thing what other person has written down and wrote it down, it is still very good, because even if you copy and write, trust me, it will enter your head. You will not forget it. Okay, I remember this was the definition. Okay, I remember this was the unit. Okay, I remember this was the formula. So it's okay. Keep typing, keep chatting, and put all that things on the chats. It shows you are paying attention. If there is a very small change for a very small time interval, then imagine it will look something like this. Maybe I was going here in a very small time interval, probably the velocity just went till here. So the change in the velocity will be very, very teeny meeny. The change in the velocity will be very, very teeny meeny. It will be like dv. dv will be the small change in velocity in a very, very small interval of time. In a very small time interval, and that very small time interval will be basically dt. Then I will get the instantaneous acceleration at that particular point. Then I will get basically the instantaneous acceleration at that particular point. So instantaneous acceleration. Just like I wrote average acceleration as change upon time, this will be nothing but a very small change in a very small time. That small change will be nothing but dv. So it will be just dv by dt. That's all. So this becomes then the formula for instantaneous acceleration. Hence I will say instantaneous acceleration is the rate of change. When I say rate of change, it means the derivative. It means the differentiation. Derivative of velocity with respect to time. the rate of change of velocity with respect to time. That is what your instantaneous acceleration is all about. Very good. So we have seen all these things: position, velocity and acceleration. And let us basically now see the basic questions on it so that you understand what it means. Okay, I have put all this printed material, whatever I have told you, okay, in the slides as well. But at the same time, remember, I also give you handwritten content like this one. These are beautiful slides which you can put it up in your notes. So that is the advantage of attending the RNA series. So let's start with some examples so that you now know how to apply these formulas. That's what the main intention of RNA is also. You should be able to solve the problems at the end of the day. So imagine I tell you there is a particle whose x coordinate changes like t square and the y coordinate changes like t cube. Example. Question is, can we write down the position, velocity, acceleration, how much is the displacement in some time, etc. So let's say in an interval in 2 seconds. Question is, find the displacement, average velocity and average acceleration. Okay, that is what we need to find. Let's try to do this question. First of all, in 2 seconds, right? So initially it will be t is equal to 0. Finally, t will be 2 seconds. So if I put time as 0, what do I get? Let's find out. First, let me write down actually the position vector. That will be better. So my position vector, guys, remember it was xi cap plus y j cap, isn't it? So x is nothing but t square. So t square I cap, y is nothing but t cube. So t cube j cap, that is my position vector. Okay, what will be my velocity vector? Think, velocity is rate of change of position. So dr by dt, meaning you have to differentiate this. That means derivative of t square with respect to I cap plus derivative of t cube with respect to time, and that is j cap. Derivative of t square is nothing but 2t x raised to n formula, n x raised to n minus 1. So 2t I cap plus t cube's derivative, 3 comes over here, reduce the power by 1. So 3t square j cap. That becomes your velocity, guys. Everybody clear till this point? Just let me know if this much is understood. Yep. That is velocity. What about acceleration? Acceleration is a rate of change of velocity. So you have to take the derivative of this. That means derivative of 2t separately, that is with I cap, and derivative of 3t square separately, and that is j cap. Remember addition rule, whenever there is a plus or minus sign, you can separate out the derivatives and individually find the derivatives. That's why we are doing that. So what is the acceleration going to be? Time's derivative is 1. T raised to 1's derivative is 1. So 2 will just come as it is. So 2 I cap plus 3 into t square's derivative. T raised to 2's derivative is 2t. So 2t into 3, 2 3s are 6. So it will become 6t j cap. Done till this point? Give me a thumbs up. Yep, very good. Most of you have got the answers also. Yes, 2 I cap plus 6t j cap. Very good, Krishna. Awesomeness. Very nice. Keep it up, keep it up, keep it up. Great. Now let's solve the next part of the problem. What is that? In 2 seconds. So let's find out what will be the original position when time is 0. Put time as 0, it will become 0 I cap plus 0 j cap. Okay. When time is 2 seconds, it will become 2 square I cap plus 2 cube j cap, which means it is 4 I cap plus 8 j cap. But that is not the question. The question is find the displacement. What is displacement? Displacement is change in the position. That means final minus initial. This minus this. Coincidentally, our displacement comes out to be the same. So 4 minus 0i is 4i. 8j minus 0j is 8j only. So displacement is 4i cap plus 8j cap meters. That is the final answer for the first part. This is done. Let's find out the average velocity. Let's find out the average velocity. Okay, average velocity is nothing but displacement divided by time. Average velocity is nothing but displacement divided by the time. Displacement we got it, 4i plus 8j. 4i plus 8j. Whole thing divided with the time. What is the time? 2 seconds. Therefore, average velocity will be 2i cap plus 4j cap meters per second. Is that done? Understood till this point? 2i cap plus 4j cap. Everyone fine till this point? That is average velocity. Now in order to find average acceleration, I will need how much is the change of the velocity. So v2 minus v0, whole thing divided by the time interval. Now the problem is I do not know what the instantaneous velocities are. Velocity at 2 and velocity at 0 seconds. So that's why I will have to go back to this. This equation helps me find the velocity at 0 and 2 seconds. Remember, this is average is different than instantaneous. So what I will do, using this, I will find what is V0. V0 is by putting 0 over here. So it will be 0i cap plus 0j cap, nothing at all. Velocity at 2 seconds, put time as 2. So it will become 2 2s are 4. So 4i cap plus 2 square 4. 4 3s are 12. So 12j cap. So these are the velocities at 2 seconds and 0 seconds. These are instantaneous. Remember, these are instantaneous. Substitute that over here. So which is 4i cap plus 12j cap, the whole thing minus 0i plus 0j. When you subtract with 0, you get the same number as it is. So that's why the average acceleration will be, time interval was how much? 2 seconds. So divided by 2. So you will get 2i cap plus 6j cap meters per second square. That is the average acceleration. Got it? Is that clear? 2i cap plus 6j cap. Understood, my dear students? If by chance the instantaneous acceleration is asked at 2 seconds, then you will just substitute time as 2 in this. So you will get 2i cap plus 6 2s are 12. So 12j cap meters per second square. But remember, then that is nothing but instantaneous. This was average value. So this shows average and instantaneous may not be the same every time. It could be definitely different. This is a very, very good question. I hope this is clear. Right? Awesome, Pratibha. Awesome, Satyashri. So that was a good question. Moving on to another question. These kind of questions are also very common. Imagine there was a car which was moving at, let's say, 8 meters per second towards the west, and then it turns towards the south and then moves at 6 meters per second in, let's say, 5 seconds. Question is, find the average acceleration during that period. Find the average acceleration during that particular period. So there was a car which was moving in a particular direction. It changed the direction. So 100% there is some kind of acceleration. Priyanka, laws of motion, it will happen next week. Yeah? Laws of motion will happen next week. I know you guys are eagerly waiting for laws of motion, circular motion, work power, energy, center of mass. Everything will go on in sequence. Don't worry. Okay, Priyanka? Right. So first let me think of the directions. This is north, this is east, this is west, this is south. I can alternatively write east as our positive x direction and north as our positive y direction by taking this point as the origin alternatively. So initially, if you notice, the car is moving with 8 meters per second in the west direction. So initial velocity will be 8 but in the negative x, so minus 8 I cap. Final velocity, look at it, is going towards south. South is negative y axis, so it is minus 6 j cap. From this, can I not find what is the change of the velocity, which is basically final minus initial? Final minus initial. So final is minus 6i, initial is minus 8i. So minus minus will become plus. So it will basically become 8i cap minus 6j cap. 8i cap minus 6j cap. That is the change in the velocity, but that is not what is asked. What is asked is the average acceleration. Remember, average acceleration is how much the velocity changed upon the time interval. So this is the change, which means it is 8i cap minus 6j cap, whole thing divided by the time interval. What is the time interval? It is basically 5 seconds. That's it. That is the answer. You can also leave it as 8 by 5 I cap minus 6 by 5 j cap meters per second square. 8 by 5 I cap minus 6 by 5 j cap meters per second square. This is in vector form, but if you are interested how much is the exact magnitude, if you are interested in the average acceleration's magnitude, then you will take the root of this. So basically it will be nothing but 8 by 5 square plus 6 by 5 square. So you can just take 8 square, which is 64, 6 square, which is 36, upon basically 25, which is nothing but 100 by 25, which is nothing but 100 by 25, which is basically root 4. That means the average acceleration magnitude will be 2 meters per second square. That is the magnitude of it, which is 2 meters per second square. But if you look at the direction wise, it is something in I, something in negative j, something in I, something in negative j. So that means the average acceleration will be somewhere in this direction. This is the direction of your average acceleration. Is that okay, everyone? This is how you solve these questions on 2 dimensions, my dear students. Clear till this point? Understood? Pakka? Very good. Now that you are understood till here, and here if you notice accelerations were changing with time. What if the acceleration is constant? Just imagine the acceleration is basically constant, basically uniform. Then a very special thing happens. If the acceleration is basically constant, this is the path taken by the particle, this is the path taken by the particle. Then if I show this is the initial velocity u, maybe this is the final velocity v, maybe this is your displacement, which is, let's say, s. Because for one dimension motion, when acceleration was constant, we can avoid derivatives and we can solve using kinematics. Same thing is applicable here also. So we can use kinematic equations, guys. There is no harm in it. So I can definitely say my final velocity is related to initial velocity. My second kinematic equation will also have u, and v square is basically u square plus. All these equations are still valid. So plus a bar into t, ut plus half a bar t square, and u square plus 2 a bar. And here there is a catch. This is a displacement. This is a dot product with the displacement. That's the only catch over here. Other than that, nothing different. It's a dot product between acceleration and displacement. So all these equations are still valid, my dear warriors. Only when acceleration is constant. You can use kinematic equations. So I can just say kinematic equations are valid. Kinematic equations are valid. If you don't like to use it in the vector form, you can still use the kinematics in 1D form by splitting it into components. Meaning something like this. You can apply kinematics only for x, or you can apply kinematics only for y. If you don't like to use the vector notation, you can apply it separately for x-axis motion and separately for y-axis motion. It is also perfectly fine. There is no harm in it. Yeah. Let me show you with an example so that you understand it. Imagine, I tell you, listen, the initial velocity is 3 I cap minus 4 j cap. Let's say the acceleration is I cap plus 2 j cap. And let's say the time that I have given to you is, let's say, 2 seconds. We have to find the final velocity and the displacement. Okay, that is the question. Now, I can use any of the two approaches. Let's say I want to do it using vectors. So here is how I'll do it. According to vectors, the final velocity is initial velocity plus acceleration multiplied by time. Is the initial velocity given? Yes. It is nothing but 3 I cap minus 4 j cap. Is the acceleration given? Yes. It is I cap plus 2 j cap. Is the time given? Yes, into 2. Can I use kinematics? Yes. Why? This acceleration, you can see, is constant. That is the reason why I can use the kinematic equations. Let's solve it. So 2 into I cap is 2 I cap. 2 plus 3, which is basically 5 I cap. 2 2s are 4, and this 4 will cancel. I'll just get 0 j cap over here. That means the velocity is just simply put 5 I cap meters per second. Done and dusted. This is using vectors. Similarly, if I have to find the displacement, I know displacement is ut plus half at square. So initial velocity, do I know it? Yes. 3i minus 4j. Time 2 plus half into acceleration is I cap plus 2j cap into t square, which means 2 square. So what do I get? 3 2s are 6. So 6i minus 8j, because 4 2s are 8. 2 and 2 will cancel. 2 and 2 will cancel. 1 2 will remain. So it will become 2i plus 4j. Simplified further, 6 plus 2 is basically 8. So 8i minus 8 plus 4 is minus 4. So minus 4j meters. So that is your displacement. 8i cap minus 4j cap. 8i cap minus 4j cap. Is that right? This is one way of doing it. But if you don't want to do it in vector form, if you do it component way, that is also okay, guys. But that will be simply and unnecessarily lengthy. For example, if you do Vx is equal to ux plus axt, final velocity in the x direction is initial velocity in the x, which is 3, plus acceleration in the x, which is 1. Acceleration in the x direction is 1, into time. Time is basically 2. So it will basically become 5 meters per second. Then similarly, Vy is uy plus ay into t. So final velocity in the y is initial velocity in the y, which is minus 4, plus acceleration, which is 2, time, which is again 2. 4 minus 4 is basically 0. So hence my final velocity will be 5 I cap. You have to solve for x and y separately. Same thing you will have to do for s also. Sx will be ux t plus half ax t square. Ux is 3, time 2, acceleration in the x is 1, time is 2. So this will give me 3 2s are 6 plus 2 2 cancels, so it will become 8 meters. Similarly, sy will be uyt plus half ay into t square. Initial velocity in the y minus 4, time 2, plus half acceleration is 2, time is basically 2, so it will become minus 8, 2 2 cancels, plus 4, which is again minus 4. So hence my displacement will be 8 I cap minus 4 j cap meters. You only think and tell me which is easier. Isn't this simpler using the vector way rather than doing x separately, y separately and then combining? Got it, everyone? Got it? Cool. Shall we go ahead? Clear? That is how you use these kinematic equations, guys. Awesome. Awesome. Now there is one more thing which you need to know. Say for example, x is given to be t square, y is given to be t minus 4. Y is given to be t minus 4. And you hear these questions where they will ask you, what is the equation of trajectory? What is the equation of trajectory? Equation of trajectory. What is the meaning of this? Let me tell you. See, trajectory means path. Equation means it will have an equal to symbol, something will be equal to something. So equation of path, meaning if our particle in 2 dimension is going some weird way, doesn't matter, however it goes, doesn't matter. It will have some x coordinate, some y coordinate at some point. It will have some x coordinate, it will have some y coordinate, some z coordinate also. If I write any equation which is only involving x, y and z, that's it, nothing else. If it is a 2D motion, it will have only x and y, okay? Only involving x and y, and there is no time in it, that is basically an equation of trajectory. That is basically an equation of trajectory. It should not involve time. It should not involve time in it. Then it is said to be a complete equation of trajectory. Even if time is there, eliminate it. How? Let's see. Let's take this example. X is t square, y is equal to t minus 4. X and y are there, time is also there. I want to get rid of time. How do I get rid of time? There are multiple ways. Just look at this. T minus 4 is there, right? So how about shifting 4 on this side? So it will become y plus 4 is equal to t. Oh, I got an idea now. Time is y plus 4. So why not use that over here? So what do I get? X is equal to, instead of time, you put y plus 4 the whole square. That's it. That is the answer. This is our equation of trajectory. You tell me the y coordinate, I will tell you the x. You tell me the x, I will tell you the y. So an equation which tells me the other coordinates, if other coordinate is given, is an equation of trajectory. So it does not involve time in it. You get rid of time from it. Yes. Understood? It's very, very simple. So let's solve some questions, guys, coming up on your screen. An aeroplane moves 400 meters north, 300 meters west, 1200 meters up. Then the displacement from the initial position is. Hint, cuboid. Hint is cuboid. Yep. Think about it. Why did I say cuboid? Come on, tell me the answer, guys. See, you're moving something in x, something in y, something in z. Basically, it's a 3D problem. Aeroplane moves 400 meters north. Let's say this is example 400 and 300 meters west. Maybe this is 300 meters. Okay. And so let's say it moves 400 meters north and then it moves 300 meters west. And then how much? 1200 meters vertically up. So this is basically 1200. Essentially length, breadth and height. So what you will be getting for the displacement is joining this vector from here to here. This is basically the body diagonal. It's just like joining this. joining this, the length of the body diagonal. That's all. So the body diagonal, this is nothing but the diagonal. The diagonal length is root of length square plus breadth square plus height square. This is a standard formula which you would have learnt in your school level. If you have not, I am telling it to you now. So just square and add them. So 400 square plus 300 square plus 1200 square. You might think these are big numbers, but take the zeros outside. So 100 squares root, you take it outside. So what will be left is just 4 square plus 3 square plus 12 square. So 100 squares root is basically 100. Here you will have 4 square plus 3 square, which is 16 plus 25 plus 144, right? So just check, sorry, 16 plus 25, 16 plus 9, my bad. 16 plus 9 plus 144, which is 25 plus 144, which is 169. So it is root of 169, which is nothing but 13. So it is nothing but going to be 1300 meters. That is the answer. Where is it? Yep. So this is a question from Tatva module. I just picked up this question from Tatva module. If you have the Tatva module, you will be able to find it. In case you do not have Tatva module, you can buy it from the links which are there in the description box below. Okay. These are a set of, many books. Each subject has different modules depending on the chapters. 11, 12 syllabus complete for all the 3 subjects, physics, chemistry, biology, involving level 1, level 2, level 3 questions, involving PYQs, as well as challenging questions which will take you beyond PYQs, as well as concepts and theory as short notes for the complete syllabus, so that you don't have to waste time making many notes. You can just go through the entire theory which is there in a very beautiful, concise manner with diagrams, everything. And if you want solutions, you can scan the QR code and you will get the complete solution of every single question, because many coaching modules don't give solutions. They only give answer key. So you will find the solutions for every single question over here. Moving on to the next one. The coordinates of a particle is given by this and this. The speed is how much? Speed is asked. Speed. Okay. Let's see. To find the speed, I will need the velocity somehow. Let's find out. If x coordinate and y coordinate are given, that means the position vector, which is x I cap plus y j cap, that position vector will be alpha t cube I cap plus beta t cube j cap. We all know velocity will be the derivative of position with respect to time. Therefore, velocity will be, take the derivative of this, alpha is a constant. So derivative of t cube with respect to time I cap plus beta is a constant, goes outside. Derivative of t cube with respect to time j cap. Okay. So what is velocity? T cube's derivative is 3t square I cap, and this is beta. Derivative of t cube is again 3t square, and that is j cap. Whatever I got is velocity. It is not speed. Remember one simple thing. Speed is the magnitude of the velocity, instantaneous velocity. So hence speed is nothing but modulus v. Modulus v means what? Take the modulus of any vector quantity, x component square, y component square, add them and put it inside the root, isn't it? So this is nothing but vx square plus vy square. So substitute what is x component over here, just check it out, 3 alpha t square, square it, plus what else is there? Beta, but 3 times. So 3 beta t square, square it. I think 3 and t square is common, so I can just take out 3t square, and inside we have alpha square and we have beta square. So that becomes the speed of the particle. 3t square, alpha square plus beta square, which is the third option. Yes, the third option over here. Got it, my dear students? Very good, Pratibha. No, it is not B. Very good, Satyashri, Krishna. Awesome. Tangjam Sirisai Ames. You are very fast. Very good. There was a student once who told me, sir, I am very quick with calculations. I was like very impressed. So I asked him, what is 22 into 7? He said 1024. I was like, that is wrong. Then I asked him, what is 25 divided by 17? He said 3.56. I was like, that is also wrong. Then I asked him, what is the square of 79? He said 234. I'm like, that is also wrong. I'm like, what are you saying? You are very fast with calculations. He's like, yes, sir, I told you I'm very fast with calculations. Where did I say I'm very accurate? Chumma, I will give you some random number. So it is becoming like that. I'm very quick, but accuracy, gone. This also is very important in the exam. You might be very fast, but if you are not accurate, you will get a lot of negative marks. But if you are very accurate, but you are not very fast, you might get, all questions right, but you have not completed the question paper. So NEET exam is a test of not just knowledge, but also speed and accuracy. All three things matter. Yeah. Problem solving, Siva, you can use Tatva module. It has already many questions in it. So you can use the Tatva module, of course. And we also have the PYQ books. So all the previous year questions, last 20 years, you can use it. So if you have already done that, then I would say, then try DC Pandey. Okay, if you have already tried this, then you can use DC Pandey objective book. Very good. Cool. Moving on to the next question on your screen, and here it is. A particle is going in X direction with 5, in Y direction with 10, then find the velocity. Oops, why did they ask such a simple question? So guys, this is just telling you how in Tatva, you have very easy questions, medial, and then, achiever section for challenging yourself. So the X velocity is 5, the Y velocity is 10. So what is the total velocity? It will be 5 I cap plus 10 j cap. But if you ask me the speed, then it will be root of 5 square plus 10 square, which is root of 25 plus 100, which is root of 125, which is basically 5 root 5. Speed will be 5 root 5, but otherwise it will be 5 I cap plus 10 j cap. Why did I do this? You'll be like, sir, question was only this much. Why did you waste our time? That is my point. Guys, whenever a question is asked, don't stop at what the question is. Go beyond the question. They ask the velocity, but maybe in the final exam, they will ask you the speed. If they ask you the speed, maybe they'll ask you velocity. If they ask you velocity, maybe next they will ask you acceleration. Maybe they will ask you something else. They will ask you direction. So always go beyond the question, whatever they have asked, and try to find what else can we find from that question. I know you might be thinking, sir, how do I know whether whatever I have found is correct or not? That's why you need a group, a set of friends, or at least one friend with whom you can cross-check. But very important that the group should be good, or the friend should be also knowledgeable, all right? Or else both of you will find the same wrong answer and you will be very, very happy. Yes, you also got 7, I also got 7. Yes, correct. But the answer is 5 root 5. So that should also not happen. That's why usually we recommend a group, because then at least one person we hope that will give the correct answer. So the moment anyone gets different answer, you will obviously think either we all are wrong or he is wrong. And then we will cross check and then you will realize, oh, this is the mistake. So that's why a group is very essential for studies, especially if you think, you need some help. You feel that always I am behind, I need somebody to help me out. So always study in groups if possible. If not, it's okay. Yeah. Moving on to the next one, coming up on your screen. Particle with certain velocity and acceleration, the magnitude of the velocity after 10, NEET 2012. Wow, amazing. In 2012, people thought the world is going to end and many students did not study for any examination. But to their surprise, 2012, nothing happened. Remember, there was a movie also. Yeah, nothing happened. So guys, yeah, so whenever you hear some negative news, ignore it, okay? Because then students ask, sir, you gave me this negative news. Tell me, should I study for the exam or not? Because or else it will be a waste. I prepared so hard for NEET examination and what's the use if the world is ending? No, the world is not ending, guys. So what do you do in this question? Initial velocity, acceleration is given. Find the velocity after 10 seconds. Use our vector form. V is u plus a into t. Initial velocity is 2i plus 3j. Acceleration is 0.3i plus 0.2j and 10 seconds over here. So 2i plus 3j over here. 0.3 into 10 is 3. So 3i plus 0.2 into 10 is 2. So 2j over here. So guys, 2i plus 3i is 5i cap. 3j plus 2j is again 5j cap. But that's your velocity. I am interested probably in the magnitude. So it will be root of 5 square plus 5 square, which is 5 root 2. 5 root 2 is D. Yes, D for AIMS Delhi. Perfecto. D for Diksha ma'am. Perfect. Is it motion in a straight line or motion in a plane? Blizzdom 360. You tell me. What do you think it is? If you see only I cap, 1D. If you see I cap plus J cap, 2D. That's the first way you should have found out. Second way you should have found out is as you are watching this video, I'm pretty sure you would have seen the thumbnail. Okay. Let's say you didn't see the thumbnail, sir, live class automatically the video plays. You should have seen the title. You don't tell me you are watching in full screen suddenly and sir, I did not see anything. Okay. Anyways, this is motion in 2 dimension. Got it? Very good. Those of you who are not yet liked the video, quickly smash the like button. What are you guys doing? Wasting time? Not even giving your Guru Dakshina. Quickly smash that like button down there. Yeah, do that. Awesome. Moving on to the next one on your screen. Yes. Now we'll go to projectile motion. See, imagine I give you a question like this. Where initial velocity is, let's say, 8i cap plus, let's say, 4j cap, or let's say 6j cap, and I give you acceleration as minus 10j cap, and if you show it, it will look like this. This is the initial velocity, something I cap, something j cap, and obviously this will be the x-axis and this would be the y-axis. This will be the point from which you have started your journey. This particle will keep moving, and maybe it will cross the x-axis at some time. I am interested, where does it cross? When does it cross? I'm interested in two things. When does it cross and where does it cross the horizontal x-axis? So I'll think, if it has to cross this particular point, if it has to basically cross this particular point over here, what is so special about this point when it is trying to cross the x-axis? When it is crossing the x-axis, what is so special about it? At this point, if you notice, the y coordinate is 0, there is some x coordinate. Yes, so basically the y coordinate is a big fat 0. Oh, that is so special about this point. Great. So now, if you ask me to find where it is and when it will cross, I will think like this. Okay, y coordinate is 0. How about writing an equation in the y direction? So if I write Sy is equal to uy into t plus half ay t square, only in the y direction, because I know the y direction coordinate is 0. Initial velocity in the y is 6. Time, do not know. Plus half into acceleration. Acceleration is negative 10 in the y direction into t square. Bring these people over here on the left hand side. So it will become 10 by 2 t square is equal to 60. 10 by 2 is 5. T and t will cancel. It will become basically 6. So time will become 6 by 5 which is basically 1.2 seconds. So at 1.2 seconds, it will cross it. At 1.2 seconds, it will cross it. Yep. Where will it cross? Where means in x coordinate, x displacement. Okay. So how about finding the displacement in the x direction? Displacement in the x direction, which is nothing but uxt plus half ax t square. Initial velocity in the x, well, 8, okay. Time, I just got it, 6 by 5. So put 6 by 5 plus acceleration, there is no I cap, so 0 into whatever t square, this is whole 0. So 8 6, right, and divided by 5. So that is your displacement right over here. 8 6, 48 divided by 5 meters. Right. So that is basically going to be 9 5s are 45. So this will be 9.6 meters. Just check this out, 9.6 meters. So we got that. Awesome. If imagine they give one more question and they tell you, when does the velocity become horizontal? When does the velocity become horizontal? Okay, I'll just add one more question to this. If they tell you, when does the velocity become horizontal and what is the coordinates of those particular points? Well, if the velocity is horizontal, means what? There is no velocity in the y direction. That means what? The velocity in the y direction is 0. Does it make sense? Only x component is remaining. Only x component is there. But Vy is nothing but uy plus ay into t. Uy plus ay into t. Just like we had Vx. It's not there here, but in some other problem we did that. So same way, Vy is u plus at. What is initial velocity in the y direction? Well, we can see it is 6 plus acceleration is -10, and time I do not know. So moving it around, 6 will be equal to 10t. So therefore t will be 0.6 seconds. We got the value of the time when the velocity becomes horizontal. When the velocity becomes horizontal or along the x-axis. What is the coordinate of those points? I have to find Sx and Sy separately. No issues, we'll find it out. So the y coordinate will be Sy, the x coordinate will be basically Sx. So Sx will be uxt plus half axt square. U is 8, time is basically 0.6 plus 0 because there is no acceleration in the x direction. 8 6 are 48, so this will be 4.8 meters. That's Sx. Similarly, Sy will become uyt plus half ayt square. That is one way of doing it. This is one way of doing it by putting time, but even without putting time we can do it. I'll tell you how. You use this Vy square is uy square plus 2ay sy. Use this equation. The final velocity at this point is 0 in the y direction. Initial velocity in the y direction is 6. Acceleration in the y direction is -10 and here it is sy. Move this over here, so that will become 20. 20 times sy is 6 square, which is 36. So basically sy will be 36 by 2 is 18, 20 by 2 is 10. So sy will be basically 1.8 meters. 1.8 meters. So we got all this. I'll tell you what is the significance of doing this entire question as such. See guys, when did it cross the x-axis? It crossed at 1.2, where? At 9.6 meters. So it crossed here at 1.2 seconds and this distance was 9.6 meters. When did it reach the topmost point? It reached the topmost point it reached the topmost point at 0.6 seconds. So it was here at 0.6 seconds, and this distance, how much was it? This distance, which is SY, it was 1.8 meters. It was basically 1.8 meters, and this much was exactly how much? It was 4.8 meters. This was 4.8 meters. Tell me one thing. Did you not see acceleration is minus 10 j cap? What does this mean? Negative 10 acceleration, 10 meters per second square in the downward direction. This is like acceleration due to gravity. This was the velocity of projection. This particular thing, whatever I have shown over here, this is the velocity with which I have thrown that object. If you observe carefully, this is 8, the height is 6. So the velocity is over here like this. This is the initial velocity. If you find the magnitude, it will be 8 square plus 6 square, which is basically 10 meters per second. Number one. If you measure this angle, tan theta, which is 6 by 8, which is 3 by 4, that means theta is nothing but 37 degrees. So you have thrown a ball under gravity at 10 meters per second, making angle 37 degrees. You have thrown the ball at 10 meters per second, making angle 37 degrees. So it reaches the highest point at 0.6 seconds, and the highest point is 1.8 meters at a distance of 4.8 meters horizontally from the original point, and it lands back on the ground at 1.2 seconds, and the range of this ball is 9.6 meters. So what do you learn from this? Projectile motion is not the actual name of the chapter. The actual name of the chapter is motion in 2D. Projectile motion happens to be a special problem when acceleration is negative 10 j cap. Did you get it? Did you get it? That is the whole purpose of this question to be solved. So don't look at projectile motion as a separate topic just for the sake of it. It is nothing but motion in 2D, where you apply kinematic equations and you can find the range, everything, etc. So whenever you throw a ball at an angle, it goes to the topmost point, but at the topmost point the velocity still remains in the horizontal. Yes, the y component vanishes out, then it will fall down over here. This distance is the range, the total time is the time of flight. Okay, this is the range, this is the maximum height. You will also see whatever time it takes to go up, same time it will take to come down. And you can see that in this particular problem. 0.6 seconds, total 1.2 seconds. It's perfectly symmetric. Not just that, this is 4.8, even this will be 4.8, totally will be 9.6. 4.8 plus 4.8 is 9.6. So this is exactly midway. This is the topmost point, right? So that is what you should understand. So guys, in case of a projectile motion, remember there will be few things which you should know. There is no acceleration in the x direction. So that's why the initial velocity will be the final velocity in the x direction, which will stay constant. It will never change. But in the y direction, it will be negative g. So the y velocity won't be a constant. Keep that in mind. This is very, very important. Talking about the formulas for maximum height. At the maximum height, at this particular point, velocity is minimum, but it is not zero. In fact, the velocity will only have the x component. Remember, the y component is the one which becomes 0. This maximum height comes out to be, remember our regular formula for vertical one dimension motion? What is the maximum height? U square by 2g. It was u square by 2g. Here I am projecting it at an angle theta with horizontal. You will just have u square sine square theta by 2g. That's the only difference. In the formula. Is that okay? So normal formula for vertical motion was u square by 2g. You just add sine square, because there is u square, you put sine square. If it was u, it will be sine. That's all. As straightforward as that. That is your maximum height. If you talk about the time of flight, when it lands over here, when it basically lands over here, you will see the speciality is the y coordinate becomes 0. So also the total time of flight is the time taken to go up 2 times or time taken to go down multiplied 2 times, because the entire motion is symmetric. And this formula is very similar to that of vertical motion. When you throw an object up, the time taken to go up and come down is 2u by g. Instead of u, you put sine theta. Because there is no square, you don't put that square over here. That's it. It is just 2u sine theta divided by g. That's the formula for the maximum height. Time of flight. Lastly, the range. Remember, in the horizontal direction, the range is the displacement which you do in the time of flight. Basically the time of flight. So basically the range will be Sx, which is ux into t plus half into 0 multiplied by t square, where t is the time of flight. Solving this, you get the range as 2u square sine theta cos theta whole thing divided by g, which you can also write as 2 sine theta cos theta is sine 2 theta. So u square sine 2 times of theta divided by g. That is the formula for range of the projectile. U square sine 2 theta divided by g. Is that absolutely clear? Everyone till this point? Awesome. Awesome. In case of maximum range, if you want to throw an object as far, you want to kick a ball, it has to go as far away as possible. So for R max, think about it, in this particular formula, I can't change u, I can't change g, I can only change sine. So basically, I will make sine 2 theta as maximum value, which is nothing but 1. 1 is the maximum value of sine theta or sine 2 theta or sine 3 theta, which means 2 theta will be 90 degrees, which means theta will be 45 degrees. So for 45 degrees, the range is maximum. And the value of the max range can be easily found out. It is not that difficult. How much will it be? Well, it will be u square sine 2 times of 45 degrees divided by g, and sine 90 is 1, so it will be just u square divided by g. So maximum range is u square by g. You can't go beyond that. And when the range is maximum, if you end up measuring the height, there is a problem also on that. If you measure the height, how much is this particular height? It comes out to be very interesting. Remember, the height formula is u square by 2g into sine square theta. Theta is basically 45. So it will become u square by 2g. Sine 45 is 1 by root 2, square it. So it will become u square by 2g multiplied by 2, which is u square by 4g, which is 1 by 4 u square by g. Deliberately I wrote it down like this because u square by g was the range max. So the maximum height reached is the maximum range that you will do divided by 4. This happens exactly at 45 degrees, R max by 4. Okay, this is a special problem which comes in some places. You might have seen that maybe in previous year papers also. Is that okay? Everyone till this point? Shall we go ahead? Let me know, guys. Done, dusted. Yes, very good. Also, you should know one more thing. When the range is maximum, the angle of projection is 45 degrees for sure. For other angles, obviously the range is not as much as before. But an interesting thing happens. If you project it at 30 degrees, maybe it will not go as far as before. But the complementary of 30 is 60 degrees. So if you project it at 60 degrees, you will see it will still land at the same place. If you project it at, let's say, some other angle like 15 degrees, it will go land somewhere even closer. Complementary angle of 15, 90 minus 15 is 75. So if you project it at 75 degrees, it will go more high, but it will land at the same place. What this tells you is basically for complementary angles, for complementary angles, the range is same. Range is basically the same, but your time period, your time of flight and your maximum height, time of flight and maximum height may be different. In fact, time of flight and maximum height will be different. You can see that very, very clearly. Height is different in both the cases. Yellow line, this one, and yellow line, this one, heights are different. Time also will be different. Okay, so that is also a very interesting thing. You might have played Angry Birds. If you shoot it at one small angle, it will reach quickly. But if there is an obstacle, what you do? You change the angle so it stays in the air for a longer time and then falls at the same place. I'm okay with more time. Have you played Angry Birds or some pocket tanks and this and that? Some video games, you might have used this concept. Yep. Moving ahead now, we will also find the ratio of these time periods and heights. How much will be that thing? So T1 by T2, if I do it, which is 2u sine theta by g, whole thing divided by 2u sine 90 minus theta, whole thing divided by g. 2u by g will cancel. So I'm just left with sine theta by sine of 90 minus theta. Sine of 90 minus theta is basically cos theta. So the ratio of the times taken will be nothing but tan theta is to 1. Tan theta is to 1 for the time of flights. Time to go up and down totally, if you take the ratio for one angle versus the complementary angle. Similarly, if you do it for height, h1 by h2, what is the ratio? It is nothing but u square sine square theta divided by 2g upon u square sine square 90 minus theta divided by 2g. U square by 2g will cancel. I'll be left with sine square theta by sine square 90 minus theta is basically cos square theta. Sine by cos is basically tan. So it will be tan square theta is to 1. That's the ratio of the heights. h1 is to h2. Tan square theta is to 1. Is that okay, everyone? So these kind of questions may be asked in your NEET. You might see some questions. Find the ratio of the times for the same range. Find the ratio of the heights for the same range. So that ratio will be either tan theta is to 1 or tan square theta is to 1. Should you remember it? No. Yes, perfect. Next, let's go to the equation of trajectory. What is the meaning of trajectory? Let's see whether you are paying attention or not. What is the meaning of trajectory? What should you get rid of? What will be the equation in terms of? Yes, you have to get rid of time and the equation will only contain x and y. Jivita, the syllabus will complete by this year end. Almost, yeah. Almost will be done with some 75% syllabus by October only. And the remaining portions will be completed by the year end or so. And we'll be, doing those final mock tests after that, or even probably by December or something. Yeah. So we have to get rid of time. So let me write down the equations in x and y. I will eliminate time. If I write down the equation x using Sx is equal to ux t plus half ax t square. Imagine this particle somewhere here, randomly, somewhere over here. This is having some velocity some coordinates. The x coordinate is this one. This is the x coordinate, and the y coordinate is this one. This is the y coordinate. I'll write down the x coordinate first, and then I'll find the y coordinate later on. So Sx, displacement in x, is how much it has moved in x direction. So that is the x coordinate. Initial velocity in the x direction. Think like this. If the original velocity was u, if the angle was theta, obviously that particular initial velocity will have two components, u cos and u sin. So this will be u cos theta, and this will be nothing but u sin theta if this is angle theta. So initial velocity in the x direction will be u cos theta multiplied by time. There is no acceleration, so just put 0. From this I get time is x divided by u cos theta. I'll just leave it as it is. Now let's go to the y direction. Displacement in the y direction is uyt plus half ayt square. Displacement in the y direction in some time is basically y. I have moved y is the coordinate. What is the initial velocity in the y direction? This one, which is u sin theta. Okay. T, I will replace it with this because I want to get rid of time, right? I want to get rid of time. So substitute time as x divided by u cos theta. Okay. Continue it. Plus half. Acceleration is down with a value of g, so minus g, into t square. Into t square. What is time? I just know it from here. It is x by u cos theta. X by u cos theta. Always get rid of time. So now this is a complete equation in x and y only. I'm very happy. So what I will do next, I will just simplify it. I'll get rid of few things. So y is equal to u will cancel. Sin by cos is tan. So x times of tan theta will be there. This negative I'll bring it out. So I'll have g and then I'll have x square. The whole thing divided by what is that? 2u square cos square theta. 2u square cos square theta. Is that right? That is the final answer. This is our equation of trajectory. X tan theta minus half g x square by 2u square cos square theta. It tells me if I know x, I can tell you y. If you tell me y, I can tell you x. That's the equation of trajectory. Is that right? Now, what is interesting in this equation of trajectory is, imagine if I rewrite this equation, which is x tan theta minus gx square by 2u square cos square theta. If I rewrite this, how? Observe. Minus g by 2u square cos square theta times x square plus x tan theta plus 0. Deliberately I have written it down like that because I want to compare it with y is equal to ax square plus bx plus c. This is a quadratic equation. X square is there. So for a quadratic equation, the graph y versus x is nothing but a parabola. Is nothing but a parabola. Is that right? Also, if a is positive, then it is upward parabola, and if a is negative, then it is a downward parabola. Also, if the constant is 0, the graph will pass through the origin. The graph will pass through the origin. In fact, all these things you can see matching over here. Hence, I will just say that this particular path which is taken, this path is a parabola, and the coefficient of the square term, which is a, is negative. So the path is a downward parabola. Downward parabola. Not just that, I can also see the graph passes through the origin right over here. You can see that it passes right through the origin. Can you see that, everyone? Also, one more thing, wherever it intersects the x-axis, that is this point as well as the origin, these are nothing but the roots of that equation. They are nothing but the roots of that particular equation. Wherever the graph cuts the axis, there are roots of the equation, and those roots are in this case real. Wherever they cut, they are basically the roots of that equation. Is that absolutely clear, my dear students? Everyone with me on this? Great, great. So you should know all these things, okay? So the path is a downward parabola, everything. So we have done all these formulas. So go through the formulas once more, and what are the main things? Horizontally, no change of speed. Vertically, the velocities change. Maximum height, u square sine square theta by 2g. Time, 2u sine theta by g. Range, u square sine 2 theta by g. Maximum range for 45 degrees. We did a special problem. Also for complementary angles, the ranges are same, but times and heights will be different. We did a special problem on the heights and time. And the equation of trajectory, which is given by x tan theta minus gx square by 2 u square cos square theta, is also a quadratic equation. That means the graph will be a parabola downward because of the negative coefficient passing through the origin. So since we have done all these things, now it's time for questions. Let's do some questions, guys. Get ready for it, okay? Because after this, one small theory point is there, which is projectile from a hill. We'll do that and this chapter is done. Yes, come on, start doing this question. Let's do this. Projectile fired with some speed at some angle has range. If the velocity be doubled at the same angle, then the range will be. Thank you guys for reminding me to have water. Only because of you I drink water, or else I keep forgetting. Thank you so much. Projectile fired with some speed at some angle has some range. The speed is doubled. What is the formula for range? Range is basically u square sine 2 theta divided by g. Angle is same, g is same. So that means range is proportional to u square. So r2 by r1 will be u2 by u1 whole square. It is mentioned that the speed is doubled. So 2u by u square, u cancels, 2 square is basically 4. So hence the new range will be 4 times the old range, 4 times of r. So that should be the answer, which is option number D. How many of you gave option number D? Very good. Awesome, awesome, awesome. Moving on to the next question on your screen. If the velocity be doubled keeping the angle, the maximum height will be how many times? What about the maximum height? Range we saw became 4 times. What about the maximum height? Again, go through the formula of maximum height. You will see the answer is very obvious. The maximum height formula is u square sine square theta by 2g. Again, height is directly proportional to square of speed. So h2 by h1 will be, new speed is double of the old speed. So it will again be 4:1. So hence it will be quadrupled. Quadrupled means 4 times. Tripled is 3 times. Half is 1 by 2. Doubled is 2:1. So answer is 4 times. That is the answer. Very good. If you ask me the time, maybe that question is also there, hopefully. Then no, it's not there. Then it will be 2 times, because time is proportional to the velocity, not square or cube or anything. So the time will be doubled. That's all. Range is given for a velocity when the angle of projection is 45. The range will be minimum if the angle of projection is, very nice question. We know that if you project a particle at 45 degrees, the range is definitely maximum. That is at 45 degrees. When will the range be minimum is the question. When will the range be minimum is the question. Which angle will you project it? Very simple, guys. Very simple. Yes, the answer is 90 degree. You throw it at 90 degree, what will happen? Think about it. At 90 degree. Don't say 180. 180 means it will go here. So if you throw it at 90 degree, it will just go and fall at the same place. It will fall at the same place. That means the range is 0, which is minimum, of course. Which is, of course, minimum. Is that right? Yep. What about 180 degree? Well, if you do 180 degree, what happens is, you are basically throwing it here. Then understand, Although you might say the range will be minimum, because if you throw it like that, it will fall over here. Usually we do not take such examples because it's like you're throwing it on the ground only. You're throwing it on the ground. So what will happen? Probably this ball will just roll over here. Or what if this was like on a pillar or something, or on a tower, then this will go down over here. So the range won't be minimum in that case. So that's why 180 degrees is not very appropriate. Although technically, if you put sine 180, you will get the answer as 0 in the formula, but it is not as appropriate as 90 degree, considering it's a single correct option examination. So you might have a debate on this, and probably if this question came in NEET exam actually, then people will be like, sir, 180 is also correct, because if we put in the formula, sine 180, sine 360 is 0. But it is not as appropriate as 90 degree, because 90 degree means it will actually land at the same place. But if you throw it horizontally, it will go somewhere. Or if it was on the top of a tower, it will fall down somewhere at some other place. Yeah. So that is why this is a tricky question. Moving on. At the top of the trajectory of the projectile, the direction of the velocity and accelerations are interesting. I've given you the theory. From that theory, you will be able to get it. I've given you the theory. From that theory, you will be able to definitely get this answer, guys. It's not that difficult. Come on, think about it. At the top of the projectile motion, what happens? I've told you that the velocity becomes horizontal. So it's only along the x-axis. But acceleration due to gravity always acts downward, negative j cap. So acceleration is always here. It's only the velocity which is here at this point. So they are mutually perpendicular to each other. So option 1 should be correct. Yes. If you look at any other point, velocity will be here or it will be here. In this situation, you will see that the angle made will be obtuse. And in this situation, you will see that the angle which will be made will be acute angle. So it will go from obtuse to 90 to basically acute angle. That's what will happen. Okay, great. Moving on to the next one. Projectile thrown with some speed and has some range. For the same angle and speed, the range on the moon will be how much? Assuming the moon's gravity is 1/6 as that on the earth. Okay, let's try to think. Do I know the range formula? Yep, u square sine 2 theta divided by g. What and all is same? The speed and the angle. That means I cannot touch the numerator, but I can touch the denominator. So this means my range is inversely proportional to acceleration due to gravity. So I can then say that the range on earth upon the range on moon, since it is inversely proportional, will be gravitation on earth will be below over here and the gravitation on moon will be on the top. So range on earth is r, range on the moon I don't know. Gravitation on the moon is 1/6 the gravity of earth, and on earth it is basically g. G cancels, 1/6 will remain. So Rm will become basically 6 goes over here, 6 times of r. So range will become more, kind of makes sense, 6r. Yes, option B for biology, B for Baswa sir. If you have seen those videos of Neil Armstrong back in the 70s where they went to the moon, you would have seen that once they make a jump, they are in the air for a very long time and they go also really high and they land at a very far away place because the gravity is 6 times less. So you throw anything up, it will go up like magically for more time, stay in the air for a long time. It will also go really high and it will also land at a place much farther than what you anticipated. On earth, it will be closer. On moon, because gravity is less, it will go really far away. Isn't it? Yes? It was a fake video. Very good. I was expecting this. So cool. It is a fake or whether it is real. That's a highly debatable thing. Even I don't know whether it is fake or real, bacha. Okay? Okay? Because there are a lot of people who consider that it is fake for many reasons. They have given some proofs. How come there was wind? How come there was this shadow, and where is that flag now? And then some people also say that if they went back then, why have you not gone now? What is stopping you from going there now? Also the computer which was used to land that spacecraft was so small. It was having hardly few kb of processing power. So using that processing power, how are you able to land there doing such complex calculations and all those things? So these are all theories, guys. Nobody knows, probably will never know, unless there might be something which we find later on in the future. That would be an interesting thing. Just like few days back, somebody discovered that aliens exist, and there is a alien body which was found in South America, if I'm not wrong. A perfectly preserved alien body. You might have seen that. So right from early 1900s, there have been sightings of UFOs, those flying saucers, unidentified flying objects, right, roaming in the space. And some people say those are fake too. Those are not real. You might have fabricated, you might have edited those videos. But then people have said that no, we have seen these UFOs. Some people even claim that they got kidnapped by aliens and then they were thrown back on the planet. Some people say that they were captured by the aliens and then they were thrown back at a different time altogether. So now we know aliens do exist because there is a perfectly preserved body of a teeny mini alien. You must see that photo of that alien. It is this small. Again, people say it is real. Some people say it is fake. But who knows? Maybe someday when the aliens visit us, we will be, we'll be convinced. Till that time, we humans feel that it is conspiracy. Okay. The velocity of a projectile at the initial point A is this much. The velocity at point B is how much? NEET 2013. Little Snake says that I am an alien myself. Very good. Thank you for admitting that. Some people say even humans are aliens. I had a very weird theory that some people say that humans can't evolve from a monkey. I mean, to think about it, our ancestors were monkeys. Their ancestors were some kind of reptiles, and their ancestors were fishes, and their ancestors were small teeny mini organisms living under the ocean. And it started right billions of years back, where a cell decided to divide itself. And then when life evolved in ocean, then some old grandfather, very, very old grandfather decided, I don't want to stay in the ocean. I'm getting out of the ocean. So that particular organism which came out on the land started adapting itself, and then finally started developing legs, and then standing on 2 feet, and then also developed intelligence, and then finally became a human. So it's a long process. Some people say it is not possible. Now again, we don't know whether it is true or false. There is one theory which says that humans were actually aliens. Other species probably evolved on Earth, but humans are aliens. Probably some spaceship long time back, thousands and thousands of years back, just landed over here, crash landed over here. And imagine those people, they had no way to go back to their home. They just crash landed here, and those babies just grew into whatever Adam, Eve, whatever you want to call them, and they just populated the earth. That's all. Just imagine if that were to be true. That would be crazy, right? If that were to be true, right? Okay. So guys, what do you think is the answer for this? 2i cap and 3j cap here. So what will happen when it lands back? Obviously, the horizontal velocity will still remain, but this velocity will be reversed. So it will be minus 3j cap. So I think that answer is D for, D for Ames Delhi. Yep, perfect. Too easy. Cool. Shall we go ahead to the next question, guys? Shall we go ahead to the next question coming up on your screen? Right, let's go. What do we have? An object is thrown along a direction inclined at 45, the horizontal direction. The horizontal range of the particle is equal to. I think we just did this kind of question. See, the range is maximum at 45 degrees, and we know that R max is u square by g. I also did that problem where height is maximum range by 4, when you throw it at maximum range at 45 degrees. So the horizontal range of the particle is 4 times of h. So 4 times of the vertical height. I think this is option number 4. Like I said, this was asked somewhere in the PYQ in a different way. So the answer is 4h. Everyone clear till this point? Shall we go ahead to the next question coming up on your screen? A ball is thrown up, returns to the ground, describing a parabolic path. Which of the following remains constant? Very easy. Is it the kinetic energy? Is it the speed? Is it the horizontal component of the velocity? Or is it the vertical component of the velocity? This also gave it to you in the theory points. Think about it. When a particle goes up and down, what happens is, in the x direction, there is no acceleration at all. So the velocity is always going to remain constant in the x direction only, because ax is 0. So hence the horizontal component of velocity is the one which remains constant. Yes, option number 3. Very good. Awesomeness. Perfecto. Let's go to the next question coming up on your screen. Wow, AFMC 2012. The equation of the trajectory is already given. G is 10, then the range of the projectile is how much? They have asked you what is the range of the projectile. All right. So think of it this way. If this is the x-axis, this is the y-axis, we know that the path which will be taken will be like that. So the range will be basically one of the roots of this quadratic equation. There will be root 1, there will be the second root number 2. That root number 2 will be exactly the range of the projectile. So what I will do is, I will take this equation, I will write it in a slightly better way. Y is equal to x common 10 minus 5x divided by 9. See if this works. I've just taken x common, 10 minus 5x by 9. Is that right? So if you find the root, when you find the root, what will happen? The y coordinate is 0. That means either x is 0 or 10 minus 5x by 9 is equal to 0. X is equal to 0 is this point. This point is the first root where x is equal to 0. So this is already taken care of. This one, if you move it around, 10 will be 5x divided by 9. 5 goes with 10 2 times. So x will be 9 2s are 18 meters. Oh, so this is the second root where x is basically 18 meters. Which means our range, what is our range going to be? Our range is also going to be 18 meters. So which is there as option number C. C for Capto, C for Captain Shreyas. Have you written it down? Yes, very good Krishna, very good Satyashri, awesome. Very good Madhumati, awesome. Thangajam, very good. Proud of all of you. So many questions we are practicing. Moving on to the next question, guys. NEET 2023. A ball is thrown from point A with some velocity at some angle to the horizontal. At the highest point B of the path, as shown in the figure, the velocity in meters per second of the ball will be how much? At the topmost point, the velocity will be only Vx because Vy becomes 0. Vy becomes 0. So what will be Vx? It will be same as Ux. Why? Because horizontal velocity always stays constant. What is Ux? It is u cos theta. What is initial velocity? 20. What is cos of 60? It is basically half. So 20 into half, which will make it 10 meters per second. Hence the answer should be option number 4, which is 10 meters per second. Is that absolutely clear? D for doctor, D for AIIMS Delhi, D for your Diksha ma'am. Perfect guys. Awesomeness. Moving on to the next question on your screen. A cricket ball is thrown by a player at certain speed in a direction. What is the maximum height? Very straightforward. Just have to use the maximum height formula, which is u square sine square theta divided by 2g. Initial speed 20, sine of 30, but then square it. 2 into gravity, which is 10. 20 square is 400, sine 30 is half. Squaring it will give you 1 by 4. So divided by 2 into 10, which is 20. 0, 0 cancels. This goes with this 20 times. 20 by 4 is basically 5 meters. So 5 meters should be the answer, which is option number 1. Yes, perfectly fine. That's how you do this question. So guys, I hope you are getting that confidence in motion in 2D and projectile motion. Yep, correct. If you're getting it, quickly smash the like button right now, immediately. If you have forgotten, do it. If you have forgotten to subscribe, subscribe the channel right now. Don't be confused like Gopika ma'am says, right? Okay, moving on to the next concept, that is horizontal projectile from some height. See, what this means is, imagine you're standing on top of a tower of certain height, and this is the ground. You're standing on top of some tower of certain height, standing on top of a tower of certain height like this, and you throw a body. Let's say you throw it like this. It will go up and it will fall down over here. Let's say you throw this body like this. You go like this and it will fall down over here. If you throw this like this, it will go and fall over here. All these are examples of projectile from some height, but this is projectile at an angle. If you see these two, these are basically projectiles from a height at an angle. And you can see why at an angle, because this is horizontal direction. You can see there is some angle involved over here. Whereas this particular diagram is actually horizontal projectile, because there is no angle now. This is horizontal projectile from a tower or from some particular height. This is what we usually study. These problems can be solved using 2D motion equations. So for these kind of questions, it's just nothing but using kinematic equations. All you have to do is use kinematic equations, just like how we did over here when we started off with projectile motion. What we did over here in this particular question. We have just been using kinematic equations in x and y direction. You want to know where it is, how it is, etc. Just use kinematic equations. There is nothing great. Even for horizontal also you can use kinematic equations. No harm, but there are ready-made formulas, so you can avoid using kinematic equations. So you can avoid using kinematic equations here because we will be seeing some ready-made formulas. So when you throw an object from some height, where it will land, how fast it will land, all these things we can find it out. So how much time it will take, all these things we can find it out. Some simple basic things, because you are throwing it horizontally, remember initial velocity in the x direction will be u, whereas initial velocity in the y direction will be 0, only because it is horizontal. There is no vertical velocity initially. Later on what happens, at any given instant, this Vx will be Ux and it will be U, and it will be basically a constant. Why? Because there is no acceleration in the x direction. There is no acceleration. So no velocity can change in the x direction. In the y direction, this velocity won't be a constant. Why is that so? Because there is acceleration of negative g, which will change the velocity in the y direction. Is that absolutely clear? Is that absolutely clear, everyone? Perfect. Now, talking about what is the time of flight. Let me tell you one very interesting fact. When you throw a ball with some speed, from some height, let's say it goes and lands over here somewhere. Let's say you increase the velocity. So what will happen is it will now go and land somewhere over here. Let's say you decrease the velocity and make it like really negligible and 0. So then it is like dropping it. So it will just go and land over here. You increase the velocity even more, doesn't matter. But in all these cases, it might land at different places, but it will take the same time to fall. This is crazy to visualize, but it is true. If you throw it slowly or really fast, don't think it will fall down faster or slower. No. Why is it that all these objects fall down at the same time? Reason is because in all of them, you will notice one common thing. Initial velocity in the x direction is there, 100%, or maybe sometimes not there. But in the y direction, always the velocity is 0. When you drop it, no velocity in the y. If you throw it horizontally, no velocity in the y direction. Acceleration in the y direction is always negative g. Displacement in the y direction is negative h. It's going down by h, so negative. So if all of them are same, hence the time is same. Hence the time is same for fall. For the fall. Did you understand it, guys? Why the time taken is the same? Yep. Now we also know what is the time taken to fall when a ball is dropped. When a ball is basically dropped, it is root of 2h by g. We have seen this formula in motion in 1D. Hence, the time for your horizontal projectile to fall is also the same. It is still root of 2h by g. There is no change at all. There is no change at all. Very, very important. The time for the fall is still going to be root of 2h by g, because all these will fall down at the same time, because this, everything is same. There is no reason for it to be different. S is ut plus half at square. S is ut plus half at square. S is same, A is same, U is same, so T is also same. Cool. Next, the range. How far does it go? How far does it go? So this is basically your range from the foot of the tower or the hill. So I think we should go with the x direction equation. Sx is ux t plus half ax t square. If I put the time as t, okay, if I put the value of time as t, capital T, which is root of 2h by g, then this will be your range. Think about it. If I wait for the complete duration, the horizontal displacement will be the range. So that's why range will be ux into t. Ax is a big fat 0. So ux is how much? It is u only into time, which is how much? Which is root of 2h by g. That's the formula. Range is speed into time. That's it. Very easy to remember. Range is horizontal speed into time, which is root of 2h by g. There is no acceleration in the x direction. Remember that. Acceleration in the x direction is 0. No acceleration. Thank you, Thangajam. Aims. Yes, perfect, perfect, perfect. Moving on to the next concept, that is the speed with which it impacts that ground. It will hit the ground with a new speed because it has come down from some height. You throw something, obviously it will land with a different speed. One thing is obvious, that the horizontal speed with which it hits will still be u, because it is a constant. Because it is a constant. And why is it a constant? There is no acceleration only in the x direction. Everybody agrees with this statement. Next, there is going to be vertical component for sure, and we can find it out like this. Vy square is uy square plus 2ay sy plus 2ay sy. This is a kinematic equation in 1D equation, but I'm applying in the vertical y-axis direction because I want to find the components of the velocity so that I can find the resultant. What is initial velocity in the y direction? Well, here only you can see there is no velocity in the y, it's completely horizontal. The name only says horizontal projectile. Sorry. Name only says horizontal projectile. What just happened? Okay, so Vy square is uy square plus 2ay sy. So Vy, I want to find uy is 0. Acceleration is negative g, which is, I can just put it as negative g over here. Displacement from here to here in the y direction, in the y-axis, is negative h. But it is negative because it is down. So therefore, I will get Vy square is equal to 2gh. I got this velocity. But I don't want that velocity, I want the resultant velocity, remember that. So the resultant velocity will be this one. Resultant velocity will be this one. So the resultant velocity will be root of Vx square plus Vy square. What is Vx square? Vx, we just got it as u. So it is u square. Vy square is nothing but 2gh. So that is the resultant speed of impact. This is the speed with which it impacts. It will have y as well as x component. Both the components will be there. Okay, thank you. Thank you, Chitra Noel. Thank you so much. Glad you are attending the class sincerely and your guys are understanding all these things. Now, you might have seen these plane problems. Where an aeroplane is going like this, and what happens is, as it keeps moving, you might have seen that there is some target somewhere and it drops a bomb. A bomb is dropped. There is a bomb which is basically dropped. Although the question says the bomb is dropped, a lot of people think that the bomb will fall here. That is not entirely true. The bomb is being carried by the aeroplane flying at that altitude. So the bomb also has that velocity like this. At the same time, also keep in mind, the bomb is at certain height h from the ground. This problem now, if you forget the plane, looks like a projectile from a hill. This looks like a projectile from a hill. So hence, this bomb will go down and fall over here. This is where your target should be. This is where your target should be. Or rather, if your target is here, you will plan it in such a way that you will drop the bomb the range distance before you reach the target. The range distance before you reach the target, and it will take same time as we have calculated as before. This is how you solve the plane problems. It's like horizontal projectile from a hill. Okay, so remember all these three formulas. Time is the same as the drop, which is root 2h by g. Second, range is speed into the time. Lastly, speed with which it hits is root u square plus 2gh. Okay, so this is how you solve the plane problems. Let's solve some questions based on this. This is your first question, guys. Come on, I want everybody to focus their attention on these particular questions. Last few questions. Yep. First question, guys. A body is thrown with some speed from the top of a tower. It strikes the level ground through the foot of the tower at a distance x from the tower. What is the value of x? Okay. Range formula basically. It is nothing but speed into time. Time is basically root of 2h by g. Speed is already mentioned as root of 2gh. So this is root of 2h by g. G root cancels. So I will be left with 2 into 2, which is 4, into h square, which is basically 2h. Answer should be 2h, which is option number 3. Let's check this out. Is it option number 3? Yep, very good. Proud of all of you. Proud of all of you. Very nice. Very nice. Moving on to the next question. An aeroplane is moving with some velocity. It drops a pocket from some height h. What is the time taken? This is like your horizontal projectile question. From some height, how much time will it take? We all know horizontal projectile is equivalent to dropping an object. So how much ever time it takes for this to fall, the same time it will take for this projectile to land over here. So it should be root of 2h by g, which is option number 4. Option number 4, everybody spammed it. Very good. If you have spammed the answer as root of 2h by g, very nice. Very good, guys. Awesomeness, awesomeness. Next question. An aeroplane is moving with some speed, drops a packet from this height, time taken, and the range. Guys, direct usage of formulas, nothing great about it. So the time will be root of 2h by g. So 2 into h. h is basically 396.9 divided by g, which is basically 9.8. Now divide this. Actually, you can take this as 10 and make this as 400 approximately. So 400 by 10 is 40. 40 into 2, 80. Just check this out. Yeah. So that will be root of 80. So root 80, guys, is close to 9. I think it will be close to 9 seconds. Just check that out. Is it or no? 80 is same as 81. 81's root is 9. So I think it should be around 9 seconds. I've done that without actually sitting and calculating this, okay, which is fine. Next is basically your range. Range is basically u into t. Horizontal speed 720. 720 is kilometer per hour. You multiply by 5 by 18, it will become meters per second. So 18 goes with 72 4 times. So 4 5s are 20. So 200 meters per second. So speed is 200. Time is basically 9. 9 2s are 18. So 1800 meters should be the answer. Yes, option number D. Option number 4. Yep, that is correct. Very nice. Awesomeness. So I've been solving really, really amazing questions, guys. Let's go to the next question coming up on your screen. A tennis ball rolls off the top of the stairs with a velocity u. Steps are b meters wide and h meters high. The ball will hit the edge of nth step if. Very brilliant question. It's there in Tatva. That's why you need to level up your game by solving these kind of questions. Let's understand what this means exactly. Ball rolls off from stairs like this, and the ball will hit the edge of the nth step. Say for example, it hits this particular step over here. The ball was going like this with some velocity. This is the first step, this is the second step, this is basically example, the third step. This is the third step in this case. Question is, what is the condition between these variables? What is the condition between these variables? Here in this case, it is the third step. So you will notice, actually this is like a horizontal projectile only. If the height of each step is h. So this will become basically 3 times of h is the height. Width is how much? B. So B. This will become 3b. This will basically become 3b. So it's like a projectile, horizontal projectile from a hill. Horizontal projectile from a hill or from some height. Instead of the third step, imagine if this was hits basically the nth step. If this was the nth step, what will be the change in the problem, guys? This will no longer be 3h and 3b. Instead, this will be n times h and this will be n times of b. Won't that be the only change in the problem? Yes or no? Won't that be the only change in the problem? Yes or no, guys? Everybody agrees with this? So now, think of this as the range. Think of this as the range. And what is the range formula? What is the range formula? The range formula is horizontal speed into root of 2 times of actual height from which it was dropped or thrown divided by g. In fact, let's square both sides. So we will get range square. So basically we'll get range square is u square into 2 times of the height divided by g. What is the range? The range is basically n times of b, square it, speed u, 2 times of height is n times of h, whole thing divided by g. So what will happen? We'll have n square b square is equal to u square 2nh divided by g. Obviously, you can notice one of the n, just got cancelled. I'm just left with one single n now. So n will be 2 times of u square h by G, take that B square below. 2U square H by GB. That's it. GB square, sorry. So that is basically option number B. Option number B. 2U square H by GB square. That is the value of N. Isn't it an amazing, amazing, amazing question, guys? Loved it? Yes or no? It looks like very difficult because some step, BIP and all is given. But actually, if you think carefully, it is not that difficult. So this is your homework question. I want to see it in the comments. And now if I don't see the homework question in the comments, I will understand you guys are not regular. Okay? Then I will also be like, okay, take students only are not interested in the homework. Why should I give homework? Why should I conduct the classes? All these thoughts will come in my mind because I'm doing this for you. So I want the answer in the comments. Okay? Immediately after the lecture is over. Okay? And yes, please like the video. If you don't like, again, I will feel that, okay, chumma, you attend it for free. No gratitude. It's like, when you are serving, you become a doctor one day and maybe you go to a village or you are treating a poor person. Maybe you are not going to expect any money. Maybe you are helping some person, advising some person. But you will expect one simple thing, one simple word of appreciation. Thank you. Thank you for treating me. That's exactly the same thing, guys. I'm just expecting one simple like, one comment and subscribe to the Vedantu NEET English channel. That's it. This is your channel. You have to talk about this channel to your friends. Make this community grow because you belong over here. And you will be nurtured here. You will be taken care of here till the very end. Remember that. Okay. Thank you so much. This was your Captain Shreyas. Go have your lunch now. Take care. I'll see you in the next NCERT line by line series and an RNA series. Take care. Bye-bye.